Hello and welcome to Math Unit 5. So hopefully in Math Unit 4 you felt a little more nursey getting to do some actual drug dose calculations and you started feeling comfortable with doing those calculations and figuring out oral drug dosing. We're going to review that a little bit in this unit as well, but we're also going to introduce parenteral drug dosing as well. So in this unit, we are going to focus on parenteral dosing. Here's the thing though, this is not a new lesson. You're not learning anything new. We're just applying it to a different situation. There are no new conversions. You've already learned all of those. So all we're doing now is applying our knowledge to calculating parenteral doses, which are doses that can be drawn up into a syringe. Now, in a later unit, the last unit, we are going to learn about syringes. You're going to learn the different sizes and how to tell them apart and what you can draw up in what syringe. I'm going to give you a little information on that in this unit, not much, but you're going to calculate those amounts that you then would be able to draw up into those syringes. So when you did oral doses, you were taught to round to a whole number, like because we were talking tablets and capsules. If it came out to 1.8 capsules, you had to round that to 2 because you can't chop a capsule up. If it came out to 1.5 tabs, well, you may round that up to 2. And I know that seems like a big round, but it's really not that bad. If the tablets are scored, you could cut 1 in half and truly give 1.5 tablets, but you're always okay to go ahead and round up to 2 as well. But now when we're talking parenteral doses, we're going to do this a little differently. The main difference between oral and parenteral drug dosing is that with oral, you had to deal with many different forms. You had tablets, capsules, you could have suspension, syrup, but with parenteral, it's always going to be in liquid form and it will be drawn up into a syringe. I know we haven't done syringes yet, but this is what your takeaway needs to be. Except one syringe, so one exception, every other syringe that we use has no ability to go to the 100ths place. So tenths is the most accurate a syringe can be. Therefore, even though you've learned how to do math and you can do it, you can go, out 2, 3, 4 places past the decimal. There's no need to do that now because with the exception of one syringe, the most accurate you can get with a syringe is to the 10ths place. So all we would do then is take our division or whatever we're doing out to the 100ths place and round back to the 10th. So in other words, 1.25 cc's would become 1.3. Why? Because there isn't a syringe that is calibrated to 1.25. They're calibrated to 1.2, 1.3, 1.4. So what you're going to do is you're going to draw it to 1.3. There's no need to go any further than that. The only syringe, this is the exception, the only syringe that can go to the 100ths place is called a TB syringe or a tuberculin syringe. It is a 1 cc syringe and it is calibrated out to the 100ths place. So if you had to draw up something and you came up with 0.28 cc's, since it's less than 1, if you had a TB syringe, you could draw that up because it is calibrated out to the 100ths. But honestly, it would still be right to round that to 0.3 when you're talking regular parenteral dosing. Now, insulin is a completely different ballgame. We'll talk about insulin when we do syringes. But for a normal parenteral dosing, if you're talking a volume greater than 1 cc, you never have to draw past the 10ths place. So if you take your math out to the 100th, you know how to round either up or down, and then that's where you're going to draw. So that's why 1.62 cc's would just be 1.6, and that's where you're going to leave it. All right, let's do some practice. Now, this is oral, so this is what you've already done. This is just making sure we remember how we did everything last week. Make sure that you're doing it right. There are 3 separate questions here. I would like you to pause the video, do all 3 of them, and then when you start the video again, I'll show you my answers. When you are trying to calculate how much medication to give someone parenterally, you're always going to be looking for an answer that's going to be in volume or milliliters, because that's what you would draw up in the syringe. So I have two questions here. The first is the doctor orders 20 milligrams and your dose on hand is 10 mg per mil. I know that one will be pretty easy. And then you have another one here of heparin. So one thing to note, whenever you have units, whether it's units of heparin or units of insulin, you never abbreviate units with the small letter U. You'll see it typed that way sometimes, but it's actually considered not great form. There have been people who, when they've written that U, they've written it sort of sloppy, and others have mistaken it for a 0, and then the patient got 10 times the amount of medication that they should have gotten. So just to be on the safe side, we always write out the word units. So go ahead and pause the video, work those two problems, and then we will go over those together. All right, the last two questions. Remember, there was no new lesson this week. This is not new information. We're just practicing it again, and we're applying it to parenteral doses instead of just oral. So here we are with another weight-based dose. The doctor orders 2 milligrams per kilo, your patient weighs 165 pounds, and your dose on hand is 100 milligrams per mil. And then you've got one more, grains 1/4 problem where the dose on hand is 60 milligrams and 2 milliliters. So once again, this is the last set of questions, so pause your video, work those two to completion, and then when you restart the video, we'll go over them together.